Good afternoon and welcome to Mr. Guevara's Maths World. This is The Way It Is. Today we're here to talk about exponential equations to the base e. Now we've certainly been talking about indical equations to other bases, 2 to the power of x, 5 to the power of x, etc, etc. Now we're turning our minds to this special number which we did talk about in class called e, which is approximately equal to 2.7183. Goes on forever, it's a rational, like pi, and we saw in class, by the way, that you can get an approximation by allowing n to approach infinity in this limit here. So, and it has special features that are very useful in calculus. For example, its derivative is the derivative of e to the x is e to the x, and consequently the integral is as well. But let's start off modestly here. We will just want to evaluate and get to know how our calculator works with e. So if we had e and we wanted to square it, this is what's going on in our calculator. We're going to press shift an ln button. Now on the Casio, that's what you do at any rate. ln means natural logarithm, so it's the logarithm of base e. The textbook talks about log base e. I talk about ln, the natural logarithm, and I use ln like your calculator does. Anyway, so to evaluate e squared, you simply press shift ln. That brings up the e. It's asking you to what power do you wish to raise e. We wish to square it. Press equals, and you should get that to 3 decimal places. Okay, so to find the cubed root of e, what you're going to need to do is press 3 for the cube bit, shift x to the power of button, and then what you're going to have to do is press the e to the shift ln button. And what is that doing? That's bringing up e. It's going to ask you then what power do you want to raise it to. Well, here the power is just 1. Okay, and you would press equals, and out would come an answer, okay, which I'll allow you to do in your own time. Moving on a bit, now we want to solve some very basic indical equations where the base is e. A couple of ways of thinking about this one, but probably the easiest is just to get this upstairs to get your denominator up to the numerator line. So e to the x is, of course, in this case, equal to e to the power of -3. And that's a number, that's the same number. So for those to be equal, that must equal that. So therefore, x equals -3. What about this one here? Well, I think what I'd be inclined to do is square both sides. Okay? So we would say e to the x, just wondering if this is the best way of doing it. Possibly, no, I can think of a better way, but I will do it the way I suggested earlier. So if I'm squaring both sides, really what I'm doing, in a long-winded fashion, is that, isn't it? Okay? So, multiplying, same base, add your indices. Therefore, e to the x equals 3x plus 3x is 6x. That's e to the 6x plus 2. So, for that to be the case, that must equal that. The indices must be equal. So, x equals 6x plus 2. Therefore, rearranging, 5x equals -2. Therefore, x equals -2/5. Okay, so we'll do some more indical equations of base e in the next clip. Thank you.